Hey everybody, this is Mr. Ainsworth, and we're going to get into some facts on the Fibonacci and golden rectangles. Let's start with the Fibonacci rectangle here. All right, it is said that if the sides are consecutive, consecutive, that means one right after the other, consecutive Fibonacci numbers, then it is a Fibonacci rectangle. For example, let me give you I'll draw a picture, just one, and we'll do this activity here on this one here later in a later lesson. But if we write down the first, first few Fibonacci numbers, 1, 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 and 8 is 13, 8, 13, 21. It keeps on going. All right, and we take any two consecutive Fibonacci numbers and make a rectangle out of it. It's called a Fibonacci rectangle. So for example, if I take the consecutive numbers 5 and 8 and I design a rectangle on that, so a 5 by 8 rectangle, all right, so let's say 5 inches by 8 inches, we call that a 5 by 8, 5 by 8, okay, rectangle. That right there, my friends, is a Fibonacci rectangle. Any rectangle whose sides are consecutive Fibonacci numbers is called a Fibonacci rectangle. We'll actually do an activity on that later on. Right now, we want to focus in on the golden rectangle and what's called the golden ratio. In a golden rectangle, it's a little bit different. All right, it's a special one. A rectangle whose sides are in proportion, okay, of the long side to the short side, all right, equals the golden ratio, which we've talked about before. It is called a golden rectangle. So, in other words, if the long side to short side, so long side to the short side, if it equals the golden ratio, which you guys already know from the prior lesson, all right, you have a golden rectangle. It is also said, and this is put in a little bit different way because we need this in the derivation and also the construction, that a rectangle is golden. That a rectangle is golden if it can be divided. All right, if it can be divided, now check this out, divided into a square, underline square here, because this is important, all right, and a rectangle, that is similar to the original rectangle. That is similar. Okay, that's a key word right there. Similar to the original rectangle. To the original, all right, rectangle. I'll talk about that as we derive it and as we work with it. All right. So a rectangle is golden if it could be divided into a square and a rectangle such that it is similar to the original rectangle. Okay, what do I mean? Okay, let me be a little bit more specific. First of all, we know that the golden ratio, which we call phi, P-H-I, that's how you say it, phi, and the symbol here is the Greek symbol phi, which is equal to 1 plus the square root of 5, all divided by 2. We know that from the prior lesson. The golden ratio is the ratio, all right, ratio, which is a fraction basically, of the length to the width. Length, okay, long side, to the width, short side. Hopefully you guys already know that. Okay, of the golden rectangle. Okay, having said that, okay, the long side divided by the short side equals the golden ratio, which is phi, or 1 plus root 5 over 2. Now, why is that? Well, let's derive it and let's figure out where it comes from, okay? And let's understand something here. If a rectangle, okay, such as the largest one here, the large rectangle A, C, D, F, the big one here, can be divided into a square, Okay, and a smaller rectangle. This is obviously a smaller rectangle here. In fact, let's use a little color so I can we can see things a little better here. So the yellow one right here, the yellow figure is a square, and the smaller one, well, that's obviously not a square because it has different length sides, right? But it is a rectangle. Okay, so if a big rectangle can divide it into a square and another rectangle, a smaller one, that is similar to the original big rectangle, then the rectangle must be golden. Okay, that's what I meant by up here. A rectangle is golden if it could divide it into two polygons, okay, two rectangles. One is a square and the other one's a smaller rectangle. That is similar here to the original, that means the big one, okay, rectangle, which is ACDF, the big one, because we obviously have a big rectangle here. So to derive the golden ratio and to see that it's actually 1 plus root 5 over 2, what we do is we use the concept of similarity. We know that the small rectangle is similar to the big one. Now the big one, let me highlight it, is in red. Okay, rectangle ACDF. Okay, so the big one is in red. Big and red. Small and blue. All right, so we got that clear. So what we want to do is set up a similarity statement, a proportion, if you will, setting up the ratio of sides of length and width so we can derive what's called the golden ratio. All right, it's the ratio of the length to the width. So what we need to do is take the ratio of the length of one side to the width, in other words, long to short, okay? Long divided by short, so keep that in mind, because width is always the shorter side. And we want to set up a proportion here. So let's start off with the small rectangle here. Well, actually, let's define some sides here first. Let's say that in the square here, we start off with a 1 by 1 square. Okay, it's a 1 by 1, 1 by 1 by 1 by 1. Okay? Our goal is to find the golden ratio, which means we got to figure out if the width of the big square is 1, what should the length be so that it has the ratio of 1 plus root 5 over 2. What should that be? So let's call it x because we don't know what it is. All right. Now starting off with the big rectangle in red, I'll color code this thing. Okay, a big rectangle, I can see that the ratio of length to width is x to 1. So x to 1, that's length to width. Long side x, short side 1. Now, that's similar and proportional to the same ratio on the smaller rectangle. So let me switch to the small one. That's proportional, because they're similar, to the same ratio on the small rectangle. Well, what is the length? Well, it's 1, right? But what is the width? This distance right here, all right, from E to D. Well, we know that it's whatever x is, subtract 1. All right, it's the total length, subtract 1, so it's x minus 1. And because they're similar, these two ratios are proportional or equal. And if we solve this proportion like we did before in prior lessons here, we would figure out how long this rectangle has to be so that it becomes golden, so that the length width ratio is exactly 1 plus root 5 divided by 2, which we already know is about 1.68 in prior lessons. I'll do that again on the calculator, okay? All right, so we cross multiply. Okay, by that I mean we got to take this product here and set it equal to this product here. So x times x plus 1, x minus 1, excuse me, x times x minus 1 is equal to 1 times 1, or 1. Distributing through, we have x squared minus 1, x, okay, minus x here is equal to 1. Subtracting 1 and setting it equal to 0, we have x squared minus x minus 1 equals 0. We understand that a is 1, b is negative 1, and c is negative 1. So a is 1, b is negative 1, c is negative 1. So what I'm going to do is I'm going to set up the quadratic formula, as we usually do. X is equal to the opposite of b, all right? So the opposite of negative 1 plus or minus the square root of negative 1 squared, which is 1, minus 4 times a, which is 1, times c, negative 1, all divided by 2 times a, which is 1. So x becomes 1 plus or minus the square root I'm going to simplify a little bit on the inside. I see a double negative here. So 1 plus 4 here, which is 5. Obviously, all divided by 2. And obviously this gives us 2 answers here. All right, but which is the one that we're looking for? So x could be equal to 1 plus the root 5 divided by 2, or 1 minus the root 5 divided by 2. Well, let's figure these out on the calculator and figure out which one makes sense. All right, and when you input them, okay, the numerator has to be in quantity. Otherwise, you're not going to get the right solution. So always put the numerator in parentheses here, and then before you divide by 2. All right, so what do we have? We have the quantity of 1 plus the square root of 5. Got to get out of the root right there. Okay, so use the right arrow key, then close it off, then divide by 2. You notice it's about 1.618, which we already know. So x is 1.618. There's phi. All right, there's your golden ratio. The other one, well, what is that? Well, let's recall the entry back, and let's change it to a minus sign, and you'll see that it becomes negative, which can't be a solution here because the width of the rectangle can't be a negative number. So it's negative 0.618. So negative 0.618. All right, the length of the golden rectangle cannot be negative. So here, it's not a valid solution. Not valid. All right, because length is positive. Because length has to be positive number, okay, is a positive number. So we got the golden ratio. It's exactly 1 plus root 5 over 2, or approximately 1.618. So we can say that the length to width ratio, if it's golden here, if it's golden, the length to width ratio is always 1.618. That's how we test to see if it's golden. What does that mean? It means if you multiply both sides by w, it means the length is 1.618 times the width. All right, it's got to be 1.6 times as long as the width. If it's not golden. All right, now how do you construct the golden ratio, or the golden, oh shoot, man, this is supposed to be the rectangle right here, so change that. How do you construct the golden rectangle with a compass and a straight edge? How do you do it? Well, believe it or not, the Greeks knew how to do it many, many years ago, okay? So what we're going to do is we're going to try it. When this requires the compass and a straight edge, and we're going to do it the way the Greeks did it. All right, so check this out. So if you need to, pause the video, get a compass and a straight edge out, and work with me. And when constructing the golden rectangle, you always start off with a square. And notice that we start off with a square right here. Let's go ahead and just denote that. We're going to start off with a square. Ooh, okay. Getting used to this here. So we're going to start off with a square. The first thing we're going to do is we are going to, I don't know, extend the side here because we got to form a rectangle when we're done. So when you start off this construction here, just go ahead and extend the side. So let's see if I can do this here. Got to figure out how to do it within the, there we go. So I want black here. What's going on here? I need a pen. I need a pen. Okay, let me pause the video and figure this out. I got a computer issue here. Okay, so I'm going to attempt to continue with this and use the technology here to show you how to construct a golden rectangle using what's called a compass and a straight edge on the computer here. So what you want to do is you're starting off with a square right here, and you're going to turn it into a golden rectangle. So the very first thing you do is you have to extend the side because you have to make it a rectangle. So get your straight edge out, line it up, and extend the bottom and the top side so that we could attempt to construct a golden rectangle. For me on the computer here, I just do this, okay? But you're going to have to use your straight edge, okay? So extend the side and extend the top. So extend the bottom, extend the top. All right, that's Pretty close. Okay, so our goal is to construct a golden rectangle from what's called a square. And the very first thing you would do here is you want to find the midpoint of the side of the square. So we can talk about it here. Let's call the corners of the square. Let's call it A, B, all right, C right here, and then point D. We have to find the two corners here of the rectangle so that it becomes golden. The very first thing we do is we find the midpoint of DC. So we find the midpoint, okay, of BC. Okay, first step. Okay, to do that, oh, not BC, DC, sorry. Misread my diagram here, so DC. All right, so what you do is you take your compass, all right, and you construct what's called the perpendicular bisector. It actually is fairly simple and straightforward. So what you want to do is you want to line your compass up at D. All right, adjust your compass a little bit more than halfway. Now, from D to C, okay? That's not halfway, that's about halfway. You want to go a little bit farther than halfway. All right, and let me change. Yeah, no, that's fine. Okay, so what we want to do is construct an arc where the radius is a little bit more than halfway. Then you're going to repeat it at point C. So bring your compass over here at point C and repeat it. All right, once you do that, you take your straight edge, all right, and you're going to line up with the intersection of the two arcs. Okay, right about there. And you're going to draw that line. So let's go ahead and do that. Okay, let's take this away. Right here, what you just did was construct what's called a perpendicular bisector, and it always runs through the midpoint. I don't know if you guys remember that from geometry a long time ago, but that's what's happening here. To find the midpoint of DC, which we're going to call it M here. All right, M for midpoint right here. There we go. That's a midpoint of DC. You construct the perpendicular bisector, and it takes 3 steps. Step 1, step 2, step 3, and I actually find 2 midpoints. I find another one up here. So we'll call this one M1, this one M2. All right, and this construction is fairly simple, and we're almost done here, believe it or not. What we do is we adjust our compass from M1 to B. So watch me first before you do it. It's always easier to watch first. So I adjust it from M1 to B. So I put my compass at M1. Okay, open up the compass so that it goes M1 to B. Right there. I'm pretty close. Not exactly on the, yeah, that's pretty close. Let me line it up, try to be as exact as possible here. So M1 to B. That's the best I can do on the computer right there. All right, and then what you want to do is construct an arc down intersecting this bottom line down here. So bring your compass down. I just found the right corner, okay, one of the corners to my rectangle. We'll call this point E. Okay, come on. I don't know why it's doing this here, so, oh, sorry. There we go. I just want to mark a point. There we go. Just want to mark a point, but not there, but here. All right, we're going to call that, oh shoot, what happened to my arc? Okay, let me repeat this here. Always challenging to do on a computer here. Okay, so there we go. Let me construct the arc again. Boom, right there. Yeah. Okay. Try one more time. Oh, come on. Let me go for this again here. Hang on. Having a little bit of an issue here. Okay, so let's try this again. There we go. Okay, so I construct an arc from M1 to B, and I find my corner of my rectangle right here, and let me see, A, B, C, D, we'll call this E right here. I repeat the process, but now go from M2 to C and go up. So now I take my compass and I go from M2 to C. Everybody say M2 to C, all right, and go up. And I just found my other corner of my rectangle right here. And we're going to call that point F. Sounds pretty good, huh? So point F right here. So hang on. Let me let's close this here. Hang on. Let me go transparent again here. There we go. All right. So right here, this is point. This is point F right here. There we go, right about there. Call that F. So now you just connect E and F, all right, with a straight edge, of course. So and for me, I'm just going to go ahead and connect using my tools right here. And so I have a rectangle that's now golden. A, F, to E. It's kind of something's going on here, all the way to, let me see here. Come on. A to F to E to back to T here. These, whoops. This right here is a golden rectangle because it's been divided into a square. All right, we started off with a square. All right, and another rectangle that is similar to the big one here. So here's another rectangle, the interior rectangle here, that is similar to the large one. And there's obviously a proof for this too. I can prove it for you. I'll do that in class here. But that's how you simply construct a golden rectangle, all right, starting with a square. You find the midpoint, and then go midpoint to the corner of the square, go down, you find the corner point of the rectangle, and you have a golden rectangle. It's pretty simple. You just have to practice. All right, and speaking of practice, you also have to do a little bit of practice here too. So, and I'm talking about your homework right here, okay? So give that a shot. It's in your book. Do page 331, 29, 30, 35, 37, 39, 40, and we'll check it in class together. All right, I'll see you in my next lesson. This is Mr. Ainsworth. See you later.